So for this problem, we want to evaluate the definite integral from 0 to 1 of x squared times 1 plus x to the 4th power times dx. Now if you note, we can expand 1 plus x to the 4th power using Pascal's triangle. And then this is just integration of a polynomial, which we already know how to do. If the exponent was, instead of 4, a 10 or a 20, that would be a pretty ugly thing to integrate. So what we want to do is use integration by substitution to make this a little bit cleaner. So let's see what we have. My list for integration by substitution says I should target the inside of the composition. The composition here is 1 plus x raised to the 4th power. The inside is 1 plus x. It's the thing we evaluate first. So I'm going to let u be equal to 1 plus x. With that, I have du equal to the derivative of the function for u times dx. Derivative of 1 plus x with respect to x is just 1. So we get du equals dx. We substitute everything back into our integral, and I wind up with, okay, so we'll have u to the 4th, and dx is equal to du, so that becomes du, and we have an x squared left over. So we have to hope that in our substitution, there's a way to get rid of the x squared. If I take a look, I notice that I can isolate x by pushing the 1 over. So we have x equals u minus 1. We could put that into the x squared, and you notice everything turns into an integral in u. So we might as well change the limits also. So we know we have a rule for converting x into u. That's just going to be take your point and then make it 1 plus your point. So x equal to 0 goes to u equal to 1. 1 plus 0 is 1. X equals 1 goes to u equal to 1 plus 1 is 2. And so now I'm looking at the integral from 1 to 2. And the 1 and 2 correspond in the same order to 0 and 1. So 0 went to 1, 1 went to 2. Now I can expand the u minus 1 squared, this step, and then we multiply through by u to the 4th, which raises the exponents by 4. This is a polynomial. We know how to do that. So the rule is to add 1 to the exponent and then flip it over. So I'll get u to the 7th divided by 7, u to the 6th divided by 6 turns to minus 1/3, and then u to the 5th divided by 5, and that's what we have here. So now we're going to evaluate at 2 and at 1 and then take the difference. So this is just pushing numbers through. So we get this, we get this. Make sure you use parentheses because you don't want to lose the distribution from this minus sign or it'll make things look wrong. Okay, so I collect all my terms, put everything over the common denominator of 105. We get 351 over 105. And this will agree with the answer we would have gotten if I had expanded the 1 plus x to the 4th power using Pascal's triangle and multiplied through by x squared. So that you can do to check your answer. Okay, that's a check using comparing this different method of integration by substitution to the expansion of this into just a polynomial we know how to do. That's one check. The regular check is when I differentiate this polynomial here with x plus 1 in for u, the derivative of this should wind up being equal to what's under the integral sign. So I put that in there. I take its derivative. So 7 comes down, cancels, exponent becomes 6. 6 come down, cancels to become 2. Exponent becomes 5. And then 5 comes down, exponent becomes 4. And I want to know if this is equal to x squared times 1 plus x to the 4th power. Well, if I take a look at this, each of these terms has 1 plus x to the 4 in it, so I can factor that out. So the first term is 1 plus x squared minus 2, just 1 plus x, because we have a fifth, and then it comes completely out of the last term, so that's just going to leave me with a 1. If I expand these, x squared plus 2x plus 1, minus 2x minus 2, and then plus 1, we notice all of this is going to cancel to leave me with an x squared, so this winds up being equal to x squared times x plus 1 to the 4th that you factored out. And so we see that's equal to our original integrand, and so our check works out.